So we've had a look at solving in the past week, and today we're going to look at solving with pronumerals on both sides. So in all the questions we've seen so far, we've only ever had the pronumerals on one side. Now they might be on both sides. Let's start with the warm-up, where they are still ones we've seen before, where everything's on one side. Take a moment, pause the video, and try each of these questions. Alright, so hopefully you've had a try to try each of those. Let's have a look at the solutions. So, for the first one, when I start with x on 2 plus 11, well, I've either got to clear the dividing by 2 or the plus 11. And because we're going the reverse order they were done, we're going to start by subtracting 11 from both sides. Subtracting 11 from 3 gives me negative 8. And then to get rid of the negative 2, the opposite of dividing by 2 is multiplying by 2. So multiplying both sides by 2, I get that x is equal to negative 16. Let's have a look at the next one. So it was 2x plus 5x is equal to negative 14. Now with this one, we have to collect our like terms before we move forward. So when I collect my like terms, if I've got 2 x-rays and 5 x-rays, in total I've had 7 x-rays. Again, it's not x squared, because we're just collecting not like terms. Now once I get to here, I need to get rid of multiplying by 7. Of course we do that by dividing by 7. So if I divide both sides by 7, I get my solution of x equals negative 2. With this one here, we're stepping it up a little bit, so we've got both collecting like terms and a few other terms to look at as well. So when I'm collecting my like terms, I see that I've got some x's, so I've got 4x, take away 1x, that's going to leave me with 3x, and I've got positive 3 plus 7, that's going to give me positive 10. So my next line, I've got 3x plus 10 is equal to negative 6. Now at this point, I decide whether I'm going to divide by 3 or subtract 10. Of course, we're going to subtract 10 first, because it's the reverse order that they were done in. So subtracting 10, what I do to one side, I have to do to the other. I end up with 3x is equal to negative 16. And then at this point, I'm going to need to divide by 3, which I do on both sides. So I end up with x is equal to negative 16 on 3. If the question says to give it as a mixed number, you can do that. Otherwise, leaving it as an improper fraction is fine. So let's get into the actual new content for today, which is solving with pronumerals on both sides. Okay. So here's our theory for today. So we can also solve equations with pronumerals on both sides. Something like that might look like 3x plus 4 is equal to 5x plus 1. Okay, so I've got x's on both sides, and I'm going to need to get them all to one side. So this is our key idea. Okay, so this is the theory that we're going to use. We can move pronumerals just like numbers, so we're going to add or subtract the pronumeral term from one side to get all the pronumerals on one side. Okay? When we're choosing which to move, we're going to move the pronumeral so that it stays positive if it's possible. So for example, with the one I've got up here, I've got the option to either subtract 3 from both sides, okay, so that would cancel out, that would give me 2x, or I have the option to subtract 5 from each side. Those would cancel out, but this would leave me with negative 2x. We'd prefer the positive, so we'll go the other way. So we're going to make that decision each time which pronumeral we want to use. So let's get into some examples. Pause if you haven't had a chance to jot that down. Okay, here's our first one. So we've got 3x is equal to x plus 10. So looking at this one, my options are either to subtract x from both sides and get our pronumerals on the left, or subtract 3x from both sides and move our pronumerals to the right. Because we want to keep things positive, we're going to subtract the x. So if I subtract the x from both sides, that leaves me with 2x plus is equal to 10, because those guys cancel out, which is the whole point. We're trying to get the pronumerals just to one side. And then at this point, this is something we were solving on the first day, we divide both sides by 2 to get our final answer of x is equal to 5. Okay, so we're going to have a look at this second example. So it's slightly more challenging because we've got constants on each side. So I'm going to start by, again, moving my pronumerals. So I make the decision, am I going to add 5x, which would give me positive 3x on this side, or am I going to add 2x, which would give me negative 3x on this side? Again, we prefer to keep it positive, so let's add 5x to both sides. That's going to give me 3x minus 4 is equal to 5. And now it's just like any problem that we've been working on in the last week. So if I add 4 to both sides, I end up with 3x is equal to 9. And then I finally need to divide by 3 to undo multiplying by 3, which gives me x is equal to 3. Of course, I can always check my answer by substituting it into the original equation. So substituting in 3 there and 3 there, I should get the same thing on both sides. Let's have a look at the most challenging type of problem where we've got brackets that we need to expand before we can do anything. So with this example here, you'll notice I've both got brackets as well as constants. Remember the brackets, we only look at the thing directly in front of it and we only look at the things inside the brackets. So now I'm expanding this bracket. I'm going to multiply 3 by 2x to get 6x, 3 by 7 to get 21, and then the 8's just going to kind of hang out. Again, this 3 is not related to the bracket, but again, I'm expanding negative 2 in. Negative 2 times 4 is negative 8, and negative 2 times negative x, negative times negative is positive 2x. So I expand everything there. Now I've got some like terms, so let's simplify those before we go any further. So I'm just going to collect 21 plus 8 to be 29, and 3 minus 8 to be negative 5. Now that I'm at this point, I make my decision. Which side am I going to move my pronumerals to? So am I going to subtract 2x to give me 4x, or am I going to subtract 6x to give me negative 4x? Again, we really prefer to keep it positive. So I end up with 4x plus 29 is equal to negative 5. Back to the problems we were looking at earlier in the week. Subtracting 29 from both sides, we get 4x is negative 34. Dividing both sides by 4, we get that x is negative 34 on 4, but of course, always reduce your fractions. So that's the concept of solving with pronumerals on both sides. If you have any questions, rewind the videos and look at the example, or stop by and ask a teacher.